Welcome to another day on the Journey Chez Chem. Well, today we get to start a new topic, and I'm so excited. So please do the warm-up questions as quickly as possible, and we'll talk about them in a moment. Now, the question number one is a little bit of review. The atomic mass of zinc, we look on the periodic chart, and we are always going to take our numbers rounded to the tens place. And therefore, I round my number to 0.4. Then the next one is aluminum. Aluminum is 27.0. Now, our units for this are either AMU or U. Either one is acceptable. The next one is calcium. Calcium is 40.1 AMU. And finally, iron is 55.9 AMU. Now, when we're doing these problems, I would always like you to use the periodic chart that I gave you in the packet the very first day of school. That's the one we're going to refer to, and that is the one that you will be given on all assessments. And that's how I found these numbers. And we look at the hundreds place to round to the tens place. Next, I wanted to name a formula, and this is a little bit of review. Perbromic acid is HbRO4. And aluminum sulfide is Al2S3. Remember, when we're doing compounds, aluminum is always +3 and sulfur is -2. And the common multiple is 6. Therefore, I need 2 aluminums and 3 sulfurs in order to get my compound to 0. Now we are going to formulas and giving the name. Now, nickel is not an alkali metal, nor is it an alkaline earth metal, and it's not one of the silly 6. So I must have a Roman numeral. And it would be nickel, Roman numeral 2, carbonate. And the last one is lead, Roman numeral 2, acetate. Yesterday you had an assessment, and I'm sure that your facilitator has graded that for you, and we'll give it back to you so that you can see what you needed to learn, and you must know your decompositions. Now, we do give you partial credit. However, those decompositions and those types of equations are going to come back again and again. You need to make sure that you review those and you figure out what you did wrong so that you don't make those mistakes again. Now I get to start on something new. You have a worksheet that is called Mole Central. Mole Central is the central concept in chemistry. It's something that you must understand. One mole is equal to 6.02 times 10 to the 23rd particles. Just like there's 12 in a dozen, if I have a dozen eggs, that means I have 12 eggs. And 1 mole is exactly 6.02 times 10 to the 23rd particles. Now, we have to use a huge number like this because atoms and molecules and formula units are tiny, tiny, tiny. And to get anything that is measurable on a scale, it requires a huge number. Now, if you read that sheet, it tells you that if you had gold, and therefore when I had zinc, and it was 65.4 AMU. Well, now comes the beauty of the periodic chart. Not only is this 65.4 atomic mass units, it is also 65.4 grams of zinc is 1 mole of zinc. And therefore, if I were to weigh out 65.4 grams of zinc, it would be exactly 6.02 times 10 to the 23rd atoms of zinc. That unifies the whole periodic chart. Any of the numbers that I take off of the periodic chart are not only the atomic mass units, they are the number of particles that it would take to get 1 mole. Now, this is a very difficult concept because it's very abstract, but it just takes a little bit of time, and we'll practice, and eventually you'll figure it out. And the light bulb will just go off and you'll understand. Now, if I had a mole of gold, I would look on the periodic chart, and I see that gold is 197.0 AMU. Well, that means it's also 197.0 grams to get Avogadro's number of particles. Now, I gave you a little scenario to help you figure out how big that number is. Well, if I had $1 for every atom of gold, I would have enough money to give every one of the 6 billion people on this earth $100 trillion. They could spend $1 million a day, every day of the year, for 275,000 years. That's a big lot of money. And so that gives you an idea of how huge that number is. It takes an awful lot of atoms to get to anything that is measurable. Now, there's also a diagram that I just love. It's called mole central. And because this is the central concept, if I have a compound like sodium bicarbonate, and I want to know its gram formula mass, or what is the mass that would be required to get 1 mole of these molecules? Well, I would take sodium from the periodic chart, and it's 23.0 AMU. And hydrogen is equal to 1.0 AMU. And carbon is 12.0 AMU. And I have 3 oxygens. So 3 oxygens, and each oxygen has a mass of 16.0. And I add them all up. And when I add them all up, I get 84.0 grams of sodium bicarbonate is equal to 1 mole of sodium bicarbonate. Now, this is a very, very important concept, that when I add up the AMUs on the periodic chart, I will actually get how many grams it takes to get exactly Avogadro's number of particles for this compound. And therefore, every compound is different, and the mass of different elements is different. If I were talking about water, H2O, I have 2 hydrogens, and there are 2 hydrogens, and each hydrogen has a mass of 1. And oxygen is 16.0. So if I have 18 grams of water, I will have exactly 1 mole. And that's what unifies the whole elements, and how we can do mathematical calculations and do quantitative measurements. And we're just beginning. And that's just so exciting to know that we can change from one compound to the other and figure out exactly how many particles we have. Now, I am going to show you 2 different types of problems where I'm going to use my mole central. Now, mole central is given to you as a guide to teach you how to do these problems, but eventually you'll be able to do them without the mole central, and especially on the assessment, you'll have to be able to do it without the mole central. So let's do an example problem. Let's say, now I'm just making up this number, so I just have a curious mind. And let's say that I have 3.75 times 10 to the -3rd molecules, and my abbreviation for molecules is MC. And my original number is always over 1. Now, mole central shows me that I must go to moles first. It's just like when you ride in a subway system. First, you have to go to the central area. The central area, or on a roundabout, you have to go to the middle in order to go further. I know that this compound I'm talking about, well, let's just pick sodium bicarbonate since we've used this one already. And I know that 1 mole of sodium bicarbonate is 6.02 times 10 to the 23rd molecules of sodium bicarbonate. And that gets me to moles. Now for moles, I can go to grams, because I know from what I did before of adding up all the AMUs that 1 mole of sodium bicarbonate is 84.0 grams. Now you need to take out a calculator, and that's what I'm going to do as well. It would be exactly 6. Now I got my nifty little calculator, and you need to make sure that you have a scientific calculator that can do exponential numbers. And we talked about that in topic 3, so I'm sure that you do have one by now. I take my original number, 3.75, exponent -3. And I need to make sure I use the plus and minus and not the minus subtraction. And I use the -3 divided by 6.02 exponent 23. Numbers in the bottom I divide, and numbers in the top I multiply. Now I need to say equals here because my calculator has an order of operation, and I wanted to do it the way I wanted to do it and not the way that it's programmed in here. So I put equals in between, because sometimes you can get a wrong number if you don't tell it exactly. And then times 84 because the number's in the top. And I get 5.2325 times 10 to the -25th. Now notice that I take the number 4 places past the decimal and I truncate it. I cut it off. And that's how we're always going to handle these numbers before we round to the right number of significant digits. Now for significant digits, I go back to my original problem. And this problem had 3 significant digits. So my answer must have 3 significant digits. I look at the 4th digit to determine if I round up the 3rd digit. And a 3 is less than 5. Therefore, my answer is 5.23 times 10 to the -25th grams of sodium bicarbonate. Now, I know that it seems tedious to write the compound in every case. However, we're establishing good habits of mind and good habits so that we can then move on and do higher level things, and it's very important to get this process. And actually tomorrow I'm going to give you a worksheet that has 10 problems on them, and you'll practice that, and the following day I will give you an answer sheet with it all worked out exactly like I like it, and then you will get a worksheet that will have 10 problems that you will hand in to be graded, because we need to check and make sure that you're following the process correctly. And that's what's coming up. So at least you know it's coming up so you can prepare. And a problem like this would be worth 10 points. This step is 2 points. This step is 2 points. 2 points for the correct number of significant digits in your answer. 2 points for the unit, and 2 points for the compound. And that gives you 10 points. And there's 10 problems. That's 100 points. And everything we do is 100 points. And that's how you do the first one. Now that's in one direction when we're going from particles, from tiny little particles, to grams of a compound. Now let's do one in reverse. I'm going to start with 5.00 grams of water. And my original number is always over 1. I have to go to mole central. And if you follow on that worksheet, you will see when you start with grams, the mass in grams on the bottom, you're following the arrows in the direction you go to mole central. And 1 mole of water is 18.0 grams of water. And you remember that we did that? We said that 2 hydrogens is equal to 2.10, and oxygen is 16.0, and therefore when we add them together, we get 18.0 grams per mole for water. And therefore my grams will cancel, and I get to moles. And then for moles, I can go to molecules. I know that 1 mole of any compound is always 6.02 times 10 to the 23rd molecules of water. And therefore, you can see that your grams cancel of water, your moles of water cancel, and you're left with what you're looking for, which is water, grams. Now let's do the math. 5 divided by 18 equals times 6.02 times 10 to the 23rd molecules equals. And my number comes out to be 1.6722 times 10 to the 23rd. Now, I look back at my original number and I have 3 significant digits. So my answer should have 3 significant digits. 1.67 times 10 to the 23rd. This 2 does not round that 7 up. 7 up, did you get that? So there we have molecules of water, and that would be my final answer. Again, this problem was worth 10 points. 2 points for the first section, 2 points for this conversion, 2 points for the correct number of significant digits, 2 points for the unit, and 2 points for the compound. And that's how we establish very good habits. Now, I may be solving only for moles, and if I'm only solving for moles, then I would only be going 1 step if I only wanted moles. And remember that gram formula mass, I add up the AMUs from the periodic chart, and we round everything to the tens place. I know you can do that, and if you're struggling with this, you might want to watch it again because it is a very abstract concept, and we know that Avogadro's number is a very, very big number, and sometimes I call it avocados because it's just more friendly sometimes than Avogadro. But we have to give Avogadro his credit. He came up with that number. What a brilliant man that Italian man was. So there you have it. We had some fun today, and you learned about moles, and we'll be practicing, and I can't wait to see you tomorrow.